Hello, how you going? Now in today's video we're going to be looking at the case where a ball hits the wall. Alright, so we've got a soccer ball coming and hitting a wall at 40 degrees. So what's going to happen here is we have to look at the change in momentum. Alright, so now you could either do this question as a momentum one or a velocity one, but let's do the momentum. So this one here has its initial momentum going in there, and we know its final momentum is coming this way. Now if I said to you that the ball weighed 1 kilogram and it was moving at 10 meters per second, then the momentum here would be 10 sec newtons and 10 sec newtons. We'll just use that as an example because it's just easy. Now we know that the change in momentum is equal to the final momentum take the initial momentum. Now if we do that as a vector addition, what that means is our final momentum going there minus our initial momentum, so that's our initial momentum going that way, so minus our initial momentum would be one going that way there, pi, and that's p final. So there, that would mean that this particular momentum vector goes away from the wall, alright, at right angles. Now if we know, just do a little dash line there, if that angle there is 40, well this angle here has got to be 50 degrees. So that angle there is 50 degrees, and so therefore that would mean that angle there is 50 degrees, and this angle here has to be 80 degrees. Now there's a couple of ways of doing this. You can either break this into two identical triangles, or you could use the cosine rule here. If I use the cosine rule to work out what the change in momentum is, then that would be equal to the square root of the two sides squared, 10 squared plus 10 squared, take 2 lots of 10 times 10 cosine of 80, and you could work out what that's equal to. Now let's do that on the calculator. Square root of 10 squared plus 10 squared, take 2 times 10 times 10, so that's 200, times by cosine of 80, and that will tell you what the length of that vector is. So it's 12.86 is the change in momentum. 86 sec newtons. Now that is away from wall. Remember, it's a vector, so you've got to give a direction associated with that. Now the other thing you could do is you could break this triangle into two separate triangles, and then I could use trig. So if we've got this triangle here, and I've got that there is 50 degrees, that there is 10, and I want to work out x, well I could use my trig for that, so we know that we've got our adjacent and our hypotenuse, so we could use cosine of 50 equals x over 10, so therefore x is equal to 10 cosine of 50, so go into your calculator, so 10 cosine of 50, and then times that by 2, you're going to get the same answer. Alright, so there's multiple ways of doing this, but the key concept here in this question is to work out what the change in momentum is, and that is simply the final momentum take the initial momentum, and it's always going to be directed away from the wall. One of the things that we are assuming here is that it's going to rebound off at the same angle, isn't it? So if that's 40 going in, it's going to come off at 40 degrees from the wall, and that's again one of those sort of properties that we would look at for most things reflecting off an object. Now the key thing is here, if the wall can't push back with that same amount of momentum, what's going to happen is that wall's going to fall over. And so obviously if we were doing a construction zone somewhere, or we're actually going to be knocking down walls, we have to make sure that that change in momentum is greater than what the wall can push back with, and then we have the wall falling over. Anyway, we'll have a go at some questions like this in class, so hopefully this helps you. You may even want to watch this video again if you're still struggling with the concept with that.